All right, SBI3U. This is video number 7. This is also the first video of the organ systems unit. So we have a new naming scheme. Oh, hey, my cat's in here. Hello, Stark. Hi. There's my cat. He's got organs as well, right? So organ systems is what we're talking about. Stark has organs. I have organs. We're going to have a new numbering scheme now. You might notice this is video 4.1. So this is the first video in organ systems. So Starkey here. He's got a lot of the same organs that I do. Pretty much all of them, actually, because he's also a mammal. Right? Some of the organs that he has that I also have are lungs and a heart and a stomach and a liver and kidneys. All of those guys. And that's what we're talking about this unit. What are these organs? What do they do? We are particularly focusing on the respiratory system, the circulatory system, and the digestive system. So those are the 3 organ systems we're talking about. So we will specifically talk about, the heart, the lungs, the stomach, the intestines, the anus and the rectum. We'll talk about the difference between the anus and the rectum. That's what we're talking about this unit. Anyway, cat aside, let's get into this one. This one's about nutrition and obesity. So we'll talk about some calories first. What is a calorie? We'll talk about the basic classification of nutrients, organic and inorganic specifically. We'll talk about fats, lipids, carbs, and proteins. We'll talk about that stuff. What are the different divisions of our macronutrients, and then we'll talk about micronutrients, some basic stuff. I don't expect that this will be a particularly long lesson, but hey, it's Monday, so why not have a little bit of a shorter one? Let's jump in. So first off, calories and obesity. This is part of the curriculum. They want us to know about health challenges and ways to kind of fix that. So first off, according to StatsCan, 31% of Canadian children are overweight, which is kind of shocking. You figure kids get a lot of time to run around. Kids have a lot of energy. You figure that they're using that energy. But yeah, 31% are overweight or obese. And obesity, generally described having a body weight 20% higher than average. So I believe 10% is overweight, and then 20% is higher than average, but that's not always accurate. They still use BMI as the measurement, and BMI is purely just body weight and height. It doesn't count muscle or any of that stuff. Muscle is more dense than fat, and so you could be really, really, really muscly and be considered obese in the edge cases. But yeah, still a lot of obese kids. So a lot of child activity programs and child nutrition programs aimed at educating kids on what kind of lifestyle choices they can make to maintain a healthier weight. What causes it? What causes obesity? Well, it's very simple. I take in more calories than you burn off, which is why up here I have, calories are a unit of energy. Calories are just energy. If you have something with a lot of calories, it just means that food is going to put a lot of energy in your body once your body processes it through the digestive system. So if you take in more energy than you burn out, your body's going to hang on to that energy in the form of weight, in the form of mass, of sugar and fat, stuff like that. You can also gain mass through muscle, but gaining mass through muscle also requires you to take in more calories than you burn off. Bodybuilders eat like crazy. They eat lots and lots of calories because they're trying to build those muscles. So typically this is due to calorie-dense food and low exercise. And it's not necessarily the number, it is the number of calories, but feeling full is part of this as well. For example, liquid calories tend to not make us feel nearly as full as solid calories. So we can drink a lot of, soda pop and not feel those calories coming into our body. But if we eat a lot of, carrots or something like that, then it fills us up and stuff like that. And of course, it's taking in more than you burn off. If you're burning it off with a lot of exercise, you can eat a lot of food. If you combine the calorie dense food with the low exercise, especially with sugary drinks, that's just a bad combination. All right. Other things are some people are genetically predisposed to become obese because this is personal, right? This is a personalized thing. You take in more calories than you burn off. Your body doesn't care about the average. Your body is your body. So if you have some kind of genetic predisposition to, for example, feel hungrier than the average person, you might be predisposed to gaining weight, or potentially, if you have some kind of genetic disease that makes it harder to move around, you're going to naturally have a difficult time burning off more calories and stuff like that. It's not a guarantee because, again, it is pure physics. It is just taking in more energy than you burn off. But it is, there are people that genetically have a harder time with this, often due to feeling hungrier or some kind of weird fat allocation metabolism thing. But you still have to take in more calories than you burn off, or else you're a medical marvel and you're breaking the laws of physics and you should go collect a Nobel Prize. All right, lifestyle still a major contributor, but again, some people find it more difficult because of various genetic factors. Nutrition. Nutrition's important. This is why this is the first lesson, talking about different fuel types, different kinds of things that we need to eat. Calories aren't everything. Calories are just the energy part. We still need to build our cells. We still need to repair stuff. We still need to think and do all of these things. So that's where we get, nutrients, nutrition. Nutrients are anything that has a useful function. So nutrients are absolutely everything. When we say nutrient, it's anything the body can use and keep and use as some kind of process somewhere, somehow. So we're going to move into classifying nutrients. So I'm going to pause while we're done with the calories thing. Now we're going to move into classifying nutrients. So I'm going to pause and update my stuff here and here. And we're back off pause. So now we're in classifying nutrients, and just to keep in mind here, a nutrient is anything the body uses to build itself. So a lot of things can be considered nutrients. Let's talk about that. Nutrients. You can have organic and you can have inorganic nutrients. Now, this is not the same as like organic carrots or grapes or whatever you buy from the grocery store. This organic and inorganic is a chemistry term. In chemistry, organic means it's made out of carbon as a main backbone. So it's several carbon molecules chained together. Things that only have one carbon molecule typically aren't called organic, with some exceptions. So for example, CO2 is not organic, but some other things with just one carbon are. And they're produced by living organisms, not, organic nutrients typically are produced by living organisms. They don't have to be. We can synthesize organic nutrients as well. Like you could get a lab and just build some vitamin A or some vitamin C or whatever. You can get it from other places, but most of the time they are organic. So carbs, proteins, fats, our macronutrients are all organic, and vitamins are organic micronutrients. These are little random molecules that our body needs for various things. For example, vitamin A is used in our eyes as part of the vision sensing system there. And that's why they say carrots are good for your eyes, even though that's kind of a myth. Inorganic foods, no carbon, but there's still nutrients. There's still stuff that we need, like calcium for our bones and sodium for our nerve cells and other things like that. But those aren't produced by living organisms, right? They're just used by living organisms. They're found in nature. So like sodium comes from salt, and salt is literally just mined out of the ground. There's salt mines, and you go and they blast it out of the ground, which is really, really cool. Calcium as well. Calcium is just found in various plants and seaweed and stuff like that, and that's how we get our calcium in milk, I guess, as well. All right, that's classifying these nutrients, organic and inorganic. Oh, I still had this up. I'm sorry. Yeah, classifying organic and inorganic. Organic is carbon. Inorganic means no carbon. No relation to organic farming, which is farming that doesn't use pesticides. Yeah. There's a further subdivision here. Macronutrients are not necessarily bigger. Like, for example, sucrose is actually quite small compared to some vitamins. Some vitamins are bigger than sucrose, which is sugar. But they typically are quite big. And the reason they're called macronutrients is we need a lot of them. Like, over 90% of what your body uses is carbs, proteins, and fats, kind of. And typically it's in that order for most people, the way that they eat. But other people, like if people are on the keto diet, they might have a lot of protein and fat and not a lot of carbs, and things like that. Or the low-fat diet, maybe they're not getting a lot of those and they just get carbs and proteins. But anyway, your body needs a lot of those. Micronutrients are smaller molecules. So vitamins and minerals, again, sometimes vitamins can be bigger than some of these, but you need them in smaller amounts. So, yeah, you don't need to eat a lot of iron. You don't need to eat nearly as much iron every day as you do carbs, proteins, and fats. That would be really weird. Stuff like that. Now we're into the macronutrients. So we're going to talk about carbs and then fats and then proteins. So I'm going to pause while I fix up all this stuff here. Okay, so we're back. Just as a reminder, now we're into our macromolecules here, carbs versus lipids versus proteins, and we're going to go through each one in step. So carbs first, then lipids, then proteins. One little keep in mind up here, all of these can actually be broken down for energy, but typically proteins are saved for other things and not used for energy, unless the body's really in a pinch, and then they'll start using the proteins as well. If you want to know why, take grade 12 biology. We talk about that in detail. Alright, so let's talk about carbs. Carbs are made of carbon, hydrogen, and oxygen. That's why they're called the carbohydrates. It's like carbon hydrated. So carbon, the carbon. Hydrated means like water, like staying hydrated, like drinking lots of water. So hydrogen and oxygen, like H2O. And the chemical formula kind of reflects that most carbs are like carbon and then 2 hydrogens and then oxygen, and it's like some kind of ratio like that. Like glucose is C6H12O6, so twice as many hydrogens as carbons and about the same number of oxygens as carbons. And sucrose, which is table sugar, is C12H22O11, so just about twice the hydrogen as carbon, is just about the same amount of oxygen as the carbon. This is your major source of energy. They're very easy to take apart. Our bodies have evolved to really process carbs very efficiently, and they're very, very good for energy. You might have heard of people loading up on carbs before a big race, like a bike race or like a hockey game or a marathon or whatever, because it's a very good source of energy. Our body knows how to do it, how to use it for energy very well. Excess carbs, though, if you take in too many carbs, they end up getting stored. Your body's not just going to poop it out, it's going to keep it. It's like, hey, that's energy, I want that for a rainy day. So it stores it We have a glycogen storage in our bodies all the time. It's kind of our like daily extra energy supply. But if we have enough glycogen, the liver is what's going to manage this. The liver is going to check to see if it has enough glycogen, and if it has enough glycogen and there's extra carbs around, it's going to store that as fat. So that's how the fatty tissue starts building up. It's the liver's job to decide whether or not to store that fat. So that's carbs. And cellulose is also a carb, but it doesn't count towards nutrition because it's not digested. So that's fiber. You'll see fiber a lot on nutritional information. It's important for having a good poop, basically. Because it's not digested, it just stays as fiber in the system, and it kind of pushes everything else with it. It gathers things up and kind of scrubs the corners and stuff like that because it's not digested. It just stays as these long strands. So this is why you'll sometimes see even carnivores eating grass. They're actually just getting some fiber to help them digest. So like this guy, he likes to eat houseplants. He'll eat the houseplants because he wants that fiber for roughage in his digestive system. He's not getting anything out of it. He's not getting any nutrients or anything. He's just trying to have a better poop. And I think we can all understand that desire. Okay, so that's carbs. Cellulose versus the rest of the carbs is an important thing. When you see them on nutritional labels, you'll see carbs, and then they'll be separated into sugar and then fiber. The fiber doesn't count towards the calorie part of the carbs. They'll still tell you it's a carb, but if it's like 16 grams of carbs and then 6 of them are cellulose or 6 of them are fiber, then you've actually only got 10 grams of energy source, of energy source stuff. And that's what carbs are used for. So again, we have a lot of energy, and then we have the completely indigestible one, but it's still important because it helps clean things up as things move through the system. Okay, next up is fats. Fats are also made of just carbon, hydrogen, and oxygen, but it's less oxygen. It's a very concentrated source of energy because it's really the carbon that gives the energy, and so you have more carbons and less oxygens, so you get a lot more energy per weight. Again, if you want the molecular stuff, just wait till grade 12. They'll teach you about it. It stores twice the amount of energy per gram as carbs do. So, I'm actually going to give you some numbers here. So just give me a sec. I'm going to pause. There we go. I fixed it. It stores 9 kilocalories per gram, so 9 calories per gram of fat. Versus carbs, which is 4 calories per gram of fat. Protein is also around 4 calories per gram of protein. So yeah, lots and lots of energy storage. So that's your main energy storage molecule, which is why when you have too many carbs, your body stores it as fat because it wants to save weight. It wants you to be able to move around but still have good energy storage. That's why we turn it into fats. It's also used for other things. It's used for insulation. As in thermal insulation to stay warm. Cell membranes are made out of fats, out of phospholipid bilayer, which is they're lipids, so they're fats. They protect vital organs, so you've got what's called visceral fat, kind of cushioning your vital organs, including, as we'll see, your heart. Your heart has a little fat blanket on it that protects it from impacts and things like that. Fat also increases the speed of nerve transmission. It's kind of like wrapping on a cable. It makes the nerves faster and insulates the nerves from each other so that there's not a lot of cross feed and stuff like that. There's other things that fat does too. So, for example, it supports your muscles and joints. You have a fat support to your muscles. If you ever look at those strongest people, competitors, they are really, really, really fat. They're not ripped like bodybuilders. Bodybuilders try to have as little fat as possible so that the muscles really bulge out. But the people that are using as much muscular strength as possible, they need a lot of fat to cushion those joints and muscles to make sure that they're not, tearing things as they're pushing incredibly heavy objects and lifting very heavy stuff. So yeah, fat is a lot of energy stores. It's a very good energy storage, which is why our body stores things as fats. But it's also very useful for other things. There are many things that fats are good for in the body. So, you do need fats, but you can choose which fats to eat. That choice is usually kind of between unsaturated fats and saturated fats. Unsaturated fats typically are from plants, and they're liquid at room temperature, because they've got these little kind of bends in them. They're bent, and that makes them kind of looser, and they kind of like slide past each other a little bit more. Meanwhile, saturated fats can lie right next to each other and stack up into a nice solid form, so they're typically solid at room temperature. Those come from animals. Plants like the liquid fats because they don't really move, so they need a way to kind of move their fat around. Meanwhile, animals actually move, and they want that solid fat to support the organs and cushion them and all that stuff. Typically, unsaturated fats, these guys are healthier if you have them in normal amounts, because these are the kinds of fats that we use for building a lot of our structures. Saturated fats are typically unhealthy because they're harder to process for the body, and they can block blood vessels. So, a lot of the times, we'll talk about a lot of the times people get heart attacks from these, and a condition called arteriosclerosis. That's the one, and it's a narrowing of the blood vessels because of fat buildup. So that's usually by saturated fats, and people need to start watching their fat intake if they're on a cardiac diet, they call it. And one of the things on the cardiac diet is to reduce the fat intake. All right, last thing is proteins. Last thing in the macronutrients is proteins. Proteins are what does everything in the body. So anytime some kind of little molecular thing needs doing, it's almost always a protein doing it. Also, hormones are made out of proteins. Muscle is built out of proteins. Nerve conduction is done by proteins. A lot of this stuff is done by proteins. Proteins are your little molecular robots. Yeah, if one chemical needs to get attached to another chemical, it's done usually through a protein, usually through an enzyme. Proteins are made out of 20 amino acids, kind of like how every word I'm saying here is made up of 26 letters. They're kind of like the letters that make the protein. There's a little star there because there is a 21st one in, I think, about 40 proteins that humans have out of tens of thousands of proteins in the body. About 40 of them have this 21st amino acid called selenocysteine in them. 9 amino acids are essential. They're called essential amino acids. You have to get them from food. This is something that vegans in particular have a difficult time with. They have to make sure that they get the essential amino acids because a lot of them do come from, or a lot of the best sources of some of them are meat. So that's something that vegans and vegetarians have to carefully track as part of their diet, is how many of these essential amino acids they get. Here's a list of them. Here's the 20 of them. Here's the 9 essential ones that we can't make. These ones are completely non-essential. We can make enough of them all the time. Just your body will just make it out of other molecules. And then conditionally non-essential is that most of the time we can make enough of them, but in times of like sickness or stress or things like that, we might run low because those resources are diverted somewhere else. So it's kind of like a nice to get in the diet, but not an essential to get in the diet as long as you're healthy. These ones are absolutely, you have to eat them because you can't synthesize them from anything else. Yeah, so that's amino acids and proteins. That's the end of that section. So we did that bit. And now we're going to talk about micronutrients. So I'm going to fix up this stuff and I'll be back in a sec. Okay, so last thing here is micronutrients. Oh, wow, I messed something up. Just a sec. There we go, that's better. Micronutrients is our last topic. And they keep in mind is now vitamins are bigger and they contain carbon. They're organic. Minerals are smaller and they're often just one atom, just a single atom. Alright, taking this one. Vitamins are organic. Here's an example. This is vitamin A. Vitamin A, see all these carbons here. So that's our chemistry definition of an organic molecule. Again, doesn't have to be grown without pesticides. The same vitamin A comes out of a normal, a carrot grown in a typical commercial operation as a carrot that's grown in an organic farm. Same exact molecule. And they're both used in the eye as the same thing because they're the same molecule. But they're organic because of these carbons. Vitamins are used for all kinds of things. They're called vitamins because they're vital. Basically, biologists worked out that if you... it's kind of sad, but the way they worked it out was they just chopped that out of the diet of like lab rats and stuff, and then the lab rats would just generally have a bad time. Sometimes, they'd have pregnant lab rats, and they wouldn't feed them a certain vitamin, and then the lab rats would just have miscarriages and stuff like that. It's a kind of a brutal time in science, but out of that came vitamins, and the names for the vitamins, like vitamin A, vitamin C, vitamin B, was kind of up to the researchers. They're loosely based on chemical properties that these vitamins have, but it's kind of a crapshoot. Yeah, if you look up the structures, there's not a lot of similarities between B9 and B12 and things like that. So that's vitamins. They're organic. They're usually bigger. And minerals are usually just single atoms, and they're used for specific tissues, specific things. So, for example, iron is in our hemoglobin. It's used to make the blood cells, so used the red blood cells. Calcium is used for bones. Everyone knows that. But calcium is also used for nerve transmission. Nerves transmit using calcium. Muscles, actually, the signal from your brain to move a muscle, one of the final signals that hits the muscle is actually a calcium signal. Magnesium is also needed for muscles and for nerve function, various other things in the body too. Chlorine and sodium are also part of the nerves. I like talking about nerves because that was my major. But chlorine and sodium used for nerves and for water balance and things like that. And potassium, also used for water balance in the kidneys. So these guys are important for water balance. Those are your electrolytes, and that's why sport drinks like Gatorade and stuff, they replace those electrolytes because they're used for water balance. Those are micronutrients. And of course, water balance means that water is also technically a nutrient, I guess. We need water to live. We're always losing water. About 90% of the liquid part of the blood is water. That's plasma. It moves all the nutrients around, especially anything that's water soluble. So you've got, a bunch of sugar and stuff just floating around in the blood. That's how your intestines are going to pull nutrients out of what they're processing. They're just using the water to absorb it, to dissolve it. It's also the extracellular fluid between the cells. The cytoplasm is made up of lots of water. It helps regulate body temperature by sweating. And it's also used in a lot of chemical reactions in the body. So a lot of times you're going to add water to things or take water away from things or join two things by taking away water or split two things by shoving a water between them and things like that. Water's great. So drink lots of water. They say 8 to 10 glasses a day, 8 to 10 cups a day. That's just 8 to 10 cups worth of water sources. So that includes if you're eating a fruit and the fruit's 80% water, all of that water is part of that. So don't try to drink actually like 8 cups a day, unless you're doing a lot of exercise outside and you're sweating and stuff like that. Then, replace your water. But when you're replacing your water, make sure you replace your minerals as well, or else you're going to have a salt to water imbalance, and you can get some serious problems, some serious conditions if that happens. All right, that's it. Just as a review, what we talked about today was nutrition and obesity, calories specifically, so calories as a unit of energy. We talked about the classification of nutrients into organic and inorganic, and then further into macronutrients and micronutrients. We talked about carbs versus lipids versus proteins. Carbs, mostly energy, but also fiber. Lipids as fats and some of the other things that fats do in our body, like thermal insulation and padding our internal organs and protecting and supporting our joints. We also talked about proteins made up of amino acids, and they do all the little molecular fiddly bits, and that's why our body typically will save proteins that we eat in order to make the little molecular robots instead of just burning them for energy. And then the last piece was vitamins and minerals and other micronutrients, and the difference between a vitamin and a mineral being that a vitamin is an organic molecule and typically larger, and minerals are smaller and often just single atoms, like you need iron to build your blood cells. And it doesn't matter where that iron comes from. You could literally eat a little bit of iron and your body could figure out a way to use it. Please don't. Please actually just get it from some kind of like bean or wherever you get your iron source. But you could theoretically get a little bit of iron and eat it and your body would use it. All right, so that's it. That's enough time. Have a nice day. Thanks for listening, and I'll see you in class.